Hello everyone. So today we are going to discuss exploratory data analysis, that is EDA part of data analytics. So we'll understand what is this EDA process and what are the terminologies and processes involved in EDA. So hope you'll get some more idea about data analytics once after completing the session. So this is the agenda for the topic. So in this session you'll learn about exploratory data analysis. So we'll understand what is EDA, why do you need EDA, what are the goals of EDA, what are the different categories of EDA, what is univariate analysis. We'll see a case study on the same, then we'll see what is multivariate analysis, and we'll see various scenarios and transformations. So exploring data is a critical step in data analysis. Exploratory data analysis, that is EDA, is used to systematically identify relations between variables when there are no prior expectations about those relations. So this helps you exploring the relationship between the variables that you have available for your analysis that you are going to use in your algorithm or the model, or the statistical model that you are preparing or that you are working on. It is a method of looking at data that does not include formal statistical modeling and inference. EDA does not involve predictive modeling. It's a different process and not exactly similar to what you do in predictive modeling. So focus of EDA is not a set of techniques but the attitude or philosophy about how data analysis should be carried out. And this is an important phase in any kind of analysis or analytics that you are doing. So there are various models and techniques by which you explore your data, you understand the pattern of the data, the behavior of the data, before you start using that data to implement some statistical model. So EDA is not just about creating data summaries, which are passive, but EDA uses the data as a window to look into the heart of the business process that generated the data. So why do we need EDA? There are several reasons why we need EDA. It is to detect mistakes, it is used to check assumptions, it is to perform preliminary selection of appropriate models, it is used to determine the relationships among the explanatory variables, it is used to assess the direction and rough size of the relationships between explanatory and the outcome variables. So these are the several reasons. Once again, to quickly go through, so it is used to do the data cleansing, identify the mistakes in the data. It is used to check the assumptions made. It is used to perform preliminary selection, determine relationship among the explanatory variables that you have, and assess the direction and rough size of the relationships between explanatory and the outcome variables. So let's understand the goal of EDA. So this assists in looking at large data by hiding certain aspects of the data while making other aspects more clear. So any particular model or any particular entity will have n number of characteristics, n number of features. Not necessary that all those characteristics or feature are relevant for the task or the model that you are implementing. So we have a mechanism by which we can focus on those relevant informations and hide some unrelevant informations which are no longer needed at that particular point of time. This is to identify systematic relations between variables when there are no or not complete prior expectations as to the nature of those relations. This is used to maximize insights into a data set, and insight implies detecting and uncovering underlying structure in the data. It is also important to know what's not in the data. So you find out the missing data, find out the missing facts and figures which are there in your data that will help you conducting your analysis better. So these are the goals of EDA. To summarize it quickly, the goals of EDA. So this is to extract important variables, this is to detect outliers and anomalies, this is to test underlying assumptions and determine optimal factor settings. These are the major objectives or goals of EDA. Then comes the different categories of EDA. So we have different categories, like we have this univariate non-graphical category, then we have this univariate graphical category, we have this multivariate graphical category, and we have this multivariate non-graphical category. These are the different categories of exploratory data analysis. Okay, more about EDA. So exploratory data analysis was promoted by this person John Taki to encourage statisticians to explore the data and possibly formulate hypotheses that could lead to new data collection and experiments. So EDA is different from initial data analysis, that is IDA, which focuses more narrowly on checking assumptions required for model fitting and hypothesis testing. So though certain processes which are involved in both are similar, but there is a thin difference. I mean, there is a unique difference between this EDA and the IDA, that is initial data analysis technique that we have. It is also to check while handling missing values and making transformations of variables as needed. So EDA encompasses IDA. You can say this is one step ahead of IDA, the initial data analysis, and there are more processes involved in this which highlights the common attributes or features of the data. So let's try to understand the first category of EDA, that is univariate analysis. So for each variable you can look at mean, median and quartiles. You can you can consider treatment of missing values, outliers and default values. You can consider the frequency distribution, that is distribution percentage, the distribution by graphs, that is you can consider of plotting this histograms like the scatter plot and the box plot. You can check for missing values and default values. You can check for outliers, which are the maximum and the minimum values. So most of the time when you are testing the efficiency of the algorithm, you'll have to perform testing several times, and each time you record the testing results, and you need to exclude the outliers, which are the extremely large or the extremely small values, because they may affect your average drastically. So you consider most of the values which are close to the mean value. Okay, consider those values which are close to each other and discard certain values which are extremely large or extremely small. Okay, this is the process of checking the outliers. Okay, so let's consider this case study of home prices. So the data from a random sample of records of resale of homes from February 15 to April 30, 1993 is captured from the files maintained by this particular realtors. So let's see how we can implement EDA in this particular case and understand the various hidden facts of the data and use it for our analysis purpose. So in this particular scenario of home prices, the data captured includes the price, that is the selling price. It could be in dollar hundreds, the square feet of the living space, that is this variable square feet, the age, which is the age of home in terms of years. It is the corner location, that is one, or we can use this numbers 1 to represent some fact and 0 for some other fact. Then this variable any, which is located in northeast sector of city or not, again to represent this true or false value, we can use this numbers 1 or 0. And then comes the next factor or the next variable called as tax, where we can determine the annual taxes. The feats, which is number out of 11 features, that is dishwater, refrigerator, microwave, disposer, washer, intercom, skylights, compactor dryer, all these facilities which are given, and the area where you are going to implement these facilities. So even this variable can be considered while deciding the home prices. The univariate analysis of the variable price gives the below result. So as you see in this chart, we can calculate the mean, we can calculate the standard error, median, mode, standard deviation, sample variance, kurtosis, skewness, range, minimum and the maximum value. So if you plot a diagram representing this, you see the distribution which is highly skewed, where resale prices for home are trending towards less than 1500. So you'll be able to draw some conclusion, you'll be able to conclude some inferences from this particular data, and these facts can be easily explored or highlighted using EDA. So exploring data requires you to consider crosstab between two variables or more, comparisons across groups, comparison with portfolio or business metrics. So these are the factors which are considered while performing this multivariate analysis. So exploring data requires you to consider slicing and dicing of data, data roll up and drill down, the multidimensional view of data to understand the multi-directional relationships. So maybe possible when you are conducting some analysis, when you are doing some analysis, there are various views that you want to represent using that analysis. So there can be business consumers who wants to see the data in its the most summarized view, or there can be end users who wants to see the data in the most specialized view. For example, if you want to see, if you are analyzing some say annual sales report, and let's say you are interested seeing only the yearly view of the data, then you can create a view which is giving you the yearly picture of the data. If there are other business users who wants to see the same analysis in half yearly mode, or there are people who are interested seeing that in quarterly mode, or the monthly mode, or the weekly mode, or the daily mode, so you can have different views of the data. You can perform these tasks called as roll up and drill down, where roll up is converting the most specialized data to its most summarized form, and drill down is exactly opposite of it. It is converting the most summarized data to its most granular view or the most specialized view. So if you have something yearly wise, you break it into half yearly and quarterly and monthly and daily, and that's the most refined view of the data. That's the most granular data. This is called as drill down. All these are features of the multidimensional data sources, where you have stored your data in the form of cubes and dimension tables and the fact tables. So these terminologies we'll see in the upcoming topics. Exploring data also requires you to consider this variable transformation, where data in the current form may not give the insight, but transformations could magnify the relations for our understanding. You may have certain data which is not too descriptive, or it is not making much sense, and just by adding few attributes or few descriptions for that particular data, you can make it more meaningful so that it starts making sense in your business scenario. So here comes the role of transformation, where you can transform the data and convert it to a view which makes sense for most of the business users. At times, only with the defined variables that you have in your data repository, you may not get the desired view that you want. You may not get the desired output that you are expecting. So at times you have to add few new variables, some computed variables, calculated variables, to make your output and the processes more meaningful. For example, in a given business scenario, if you have the price value and the quantity value given, and if you want to compute the total price, you can create a new variable, total price, which is multiplication of price and quantity. So using multivariate analysis, you'll be able to answer questions like, does the data indicate a relation between taxes and the market value of homes, and many other similar questions. This is an important question of concern to citizens as policy matters, as well as a personal financial concern. Now we'll consider various scenarios for this particular task. For example, will the linear relation between taxes and resale value be influenced by a few under tax expensive homes, or what will happen if we transform these two variables? So when it comes to transformation, a linear relation is now better explained with the log transformed variables. As you see in this diagram, we have some more implementations of this particular concept implemented in the next module, the next topic that we have. Thank you very much.